Hey again, everybody. I know some of you are still having some trouble on the sigma notation aspect of these, so I'm going to go back and do on page 337. This is number 22. Okay, so I'm just going to do another sigma example all the way through, see if we can't, tie off any of those loose ends. So the original problem looked like this. It's from 1 to 4, x squared plus 2x minus 5 dx. And our goal, of course, is to turn this into a sigma representation. So this is going to be the limit as n goes to infinity for sigma from I equals 1 to n of f of x sub I times delta x, and our goal is to figure out what delta x is and figure out what f of x sub I is. So here we go. Delta x is b minus a over n, so 4 minus 1 over n, which is 3 over n. X sub I is my starting location, which is 1, plus delta x times I. And f of x sub I is going to have to be then x squared, 1 plus 3 over n I squared, plus 2 times 1 plus 3 over n I minus 5. Alright, now let's go ahead and resubstitute. So this is going to be the limit as n goes to infinity for sigma and f of x sub I. Okay, so that's going to be this. Now, I guess I'll take one line and not do any simplifying, but we're going to have to expand that out at some point. So I'm just copying. I haven't done anything yet. So this is right. So this is f of x sub I. I still need delta x. Delta x is 3 over n. So this is going to be times 3 over n. Alright, so let's start expanding. So this is going to be, let's see, 1 plus 6 over n I, right? So it's 2 of these. So 1 times 3 over n I, but it's 2 of them, so 6 over n I. Plus, now I got to square this thing, 9 over n squared I squared. And that takes care of this one part. Still have this now. Plus 2 plus 6 over n I. Minus 5, and that whole thing is still being multiplied by 3 over n. Alright, so let's go ahead and take care of that and see what we can simplify. Let's see. I've got 1 plus 2 is 3, minus 5 is negative 2. That takes care of that. And I've got 6 over ni plus 6 over ni, so that's 12 over ni. 12 over ni. That takes care of those. And this I haven't done anything to. 9 over n squared, I squared. Still 3 over n multiplying through. So all I did was I simplified all the like terms. So now this becomes negative 6 over n plus 36 over n squared I plus 27 over n cubed I squared. And now we get to do all our fancy stuff, okay? Let's see. We've got, if you're looking at this, we could break this apart into the pieces, but I hope at this stage, you're looking at this and you realize you can say, okay, I'm just going to look at this part, then I'm going to just look at this part, and then this part. So if I do that, this goes to just negative 6. So here. So limit, I'm not going to do the limit yet. But this part goes to negative 6 because I have negative 6 over n, again, plus negative 6 over n amount of times, so that's negative 6. The 36 over n squared I, if I take care of the formula for I really have 36 over n squared, n times n plus 1 over 2, plus the 27 over n cubed, and then I have a formula for I squared. That's n times n plus 1 times 2n plus 1 over 6. And now I just took care of all my sigmas. I used my basic concept of addition for this one. I have my I formulas for this one, and the rest now we can apply the limit. So if I apply the limit, negative 6 is just negative 6. The n squared here and the n squared here, that just goes to 1. So I'm left with 36 over 2, which is 18. This turns into 2n cubed over here, right? N times 2n is 2n cubed over n cubed. So this just goes to 2. So I have 2 over 6 which is 1 over 3, divided by 27 divided by 3 is just 9, so plus 9. So if I put that all together, I get, I believe, 21. Okay, that's 12 plus 9 is 21. Now what's cool about now is if you've gotten as far as looking at the other videos and seeing how this translates into, using our integration technique with antiderivatives, we can actually check that. Okay, let's do this. Let's do the same problem using our new techniques, new school. So if I have the integral from 1 to 4 of x squared plus 2x minus 5, I'm going to use my fundamental theorem. So that's x cubed over 3 plus x squared minus 5x evaluated between 1 and 4. So that's 4 cubed over 3 plus 16 minus 20 minus 1/3 plus 1 minus 5. So that's, what's that, 64 thirds plus 16 minus 20 minus 1/3 minus 1 plus 5. So that's 64 thirds minus 1/3 is 63 thirds. 16 minus 20 is -4. -5. These all just cancel. 16 minus 20, -4. -5 plus 5 is 0. 63 thirds is 21. Hey, how about that? Positive 21 both ways. Okay, so hopefully, actually this is a pretty good review. This really takes you from start to finish to see how the two things can both work. So here's another sigma example, all the way through, and then turning it into a fundamental theorem problem all the way through. It's not a substitution problem, so it didn't make it all the way to the end, but it's still doable. Okay, hopefully this helps. This is number 22 from page 337, done both ways. Old school, which is the way they would have intended on page 337, and new school, which is from 350 whatever, 355, whatever that next section was. Okay, hopefully this helps. Let me know if you need anything else, and I'll try to help out. Okay, talk to you later. Bye.